Advanced Math, Lesson 18, Part 2. We're going to be going over three types of problems. The first one is sum of digits of a two-digit counting number. So if we're trying to figure out the digits of a two-digit counting number, the second type of problem is chemical mixture problems, where we've got one solution plus another solution, and we want to get a desired third solution of a certain amount. And the last one is going to be molecular weight problems, where we try to figure out the weight of a given element in a particular molecule or atom, things like that. Let's start with the first one. So this problem, 18.4. Let's get our zoom right. They tell us the sum of digits of a two-digit. Whoop, hold on. There we go. So the sum of the digits of a two-digit counting number is 5. When the digits are reversed, the number is 9 greater than the original number. What was the original number? So to figure this out, we have to understand some arithmetic about two-digit numbers. Now, if we look at the two-digit number 58, that number 58, the 5 has a place value of 10, which means that 5 has a value of 50. The 8 has a place value of 1, which means the 8 has a value of 8. What that means is the first digit is equal to being multiplied by 10 plus the second digit. So 5 times 10, 50, plus 8, 58. Now, if we reverse the numbers, the second digit, what was originally the second digit, now has a value of 80, not 8, and then the first digit now has a value of 5, not 50. So, again, 8 times 10, 80, plus 5, 85. Now, algebraically, what that means is our original number has a first digit and a second digit. And algebraically, that means if we take 10 times the first digit and add it to the second digit, we have the number. If we switch the numbers and we take 10 times the second digit and add it to the first digit, we have the numbers reversed. So we're going to use that to solve this problem. They tell us the sum of the digits of the number is 5. So if the digits are first and second, I know that if I add the first to the second, I'm going to get a value of 5. That's equation number 1. Great. Then they tell us that when the digits are reversed, so reverse digits, so I've got 10 times the second plus the first. So when the digits are reversed, the number is 9 greater than the original number. So reverse digits equals 9 greater than the original number, which is 10 times the first plus the second. So now I've got an equation. I've got something that I can plug into it. And I can start solving through substitution. So before I substitute, I'll go ahead and solve this equation for one of the unknowns. And we'll solve it for f. Okay? So if I subtract s from each side, what's going to happen is I'm going to get f equals 5 minus s, or 5 minus the second number. So I'll take this value and I'll substitute it here and here for f. So let's rewrite this. We have 10s plus 5 minus s equals 10 times 5 minus s plus 9. Okay, so let's distribute. We'll distribute the positive. That just becomes 10s plus 5 minus s. Whoops, that's an 8. Minus s. So that doesn't change any signs. We distribute this 10. We get 50 minus 10s plus s plus 9. And now we've got some like terms that we can combine. So this 10s and this negative s combine to become 9s plus 5. Let's see here. This negative 10s and this s become negative 9s. And then 50 and 9 combine to be positive 59. From here, we'll go ahead and get the 9s over to this side with the other 9 so they can be buddies. And then we'll go ahead and move this 5 over here with the other whole numbers. Those two amounts will cancel. 9s plus 9s gives us 18s. And 59 plus 5, minus 5. Oh, I didn't catch that. 59 minus 5 gives us 54. Okay. We divide each side by 18. and then we reduce. I don't know how many times 18 will go into 54, but through my divisibility rules, I know both of these are divisible by 3. Or, you know what, even my times tables, I know they're both divisible by 6. I know that 6 times 9 would give me 54, so that will reduce to 9. And then 6 times 3 gives me 18, and 9 over 3 reduces neatly down to whole number 3. So the second number, or the second digit, is a 3. S equals 3. And then I'll take that and I'll plug that into here. So the first digit equals 5 minus the second digit, which is 3. 5 minus 3 is 2. So the first digit equals 2. And that means my number is 23. And that's my answer. Next, let's move on to percent mixture problems. Now these are very similar, very, very similar to nickel and dime problems. They just take a different type of thinking. You got to think about them a different way. So the problem says to get 1,000 gallons of a mixture that was 56% alcohol, it was necessary to mix a quantity of 20% alcohol solution with a quantity of 80% alcohol solution. How much of each was required? So one way to think of it is the value of each solution is recognized in its percent of alcohol content. So you can think of that like the value of your nickels and dimes. And then the number would be the gallons. So the way we could do this is we're going to add solution 1 plus solution 2 to get a value of 1,000, right? So that's one equation. We could say solution number 1 plus solution number 2 going to equal 1,000, and that's milliliters. So we think of it in terms of volume, and then we'll think of it in terms of percent or value. They tell us one solution had a 20% value, so we could put 20 times solution number 1, and then the other solution had an 80% value, so I could put 80 times solution number 2. And then when we combine those, we got a 1,000-gallon mixture that had a 56% solution. So then we'll take 56 and we'll multiply that by 1,000. So again, this is just like a nickel and dime problem. We had number of nickels plus number of dimes equals this much money, and then value of nickels plus value of dimes equals money times value. So the extra thing here is this solution percent of the last problem. So all we do here is we would subtract the second solution from each side, and then we know that solution 1 is equal to 1,000 minus solution 2. So then I'll substitute that here. I have 20 times 1,000 minus solution 2 plus 80 solution 2 equals 56,000. I'll go ahead and multiply that. From here I'll distribute, and then 20 times 1,000 gives me 20,000 minus 20 solution 2 plus 8. Oh, sorry, not 8, 80 of solution 2. I forgot to add that 0. Equals 56,000. Okay, I'll start combining like terms. 80 minus 20 gives me 60. So I've got 60 times solution 2, and then I'll go ahead and subtract 20,000 from each side. That will cancel. Sorry. And then 56 minus 20 gives me 36,000. So I've got 60 times the second solution equals 36,000. Divide each side by 60. And then I can trade a 0 for a 0, and then I know that 6 will go into 36 6 times. So I've still got a 6, I've still got 2 zeros, which means my answer is 600. So that's 600 milliliters of solution 2. And then let's look back at our problem. The first solution was 20%, second solution 80%. So that's 600 milliliters of the 80% solution. Now, if solution 1 plus solution 2 has to equal 1,000, all I have to do is, or we can say that solution 1 is equal to 1,000 minus solution 2. Solution 1 equals 1,000 minus 600, which means solution 1 is equal to 400. So then that's 400, oh, I'm sorry, these aren't milliliters, these are gallons. 600 gallons, and then 400 gallons of the 20% solution. And that is our answer. All right, now the very last problem is molecular weight problems. These are pretty interesting. They tell us in 18.7, and these are actually a review from Algebra 2. They tell us that the weight of the carbon in the container of C3H7 chlorine was 113 grams. I just realized we're reading crooked. Was 113 grams. What was the total weight of the compound? And then they tell us that the molecular weight of carbon is 12, the molecular weight of hydrogen is 1, and the molecular weight of chlorine is 35. So we need to understand how to read atomic composition. So when we see C sub 3 H sub 7 Cl, that's saying that there's 3 atoms of carbon, 3 atoms of hydrogen, or I'm sorry, 7 atoms of hydrogen, 1 atom of chlorine. And then down here they're saying 1 atom of carbon weighs 12, 1 atom of hydrogen weighs 1, 1 atom of chlorine weighs 35. And then we're going to use that to find the ratio of the total weight of the compound. So what they do is this right here. They multiply each weight by how many atoms there are. So they're going to take 12 times 3 for the 3 atoms, which means the total weight of carbon is 36. Take hydrogen times 7. Total weight of hydrogen is 7. Chlorine times 1, 35. So then they get a total weight of the compound is 78. Now we have to think of this in ratios. So we could think of this like this. So the total is going to equal 78. And the problem tells us that the weight of carbon in the container was 113 grams. So we have to come up with a ratio of carbon to the total weight, which in this case is going to be 36 to 78. 36 to 78. Now that weight of carbon is not just the weight of carbon being 12, it's the 3 carbons in the atom or the molecule. So we have this ratio of 36 to 78 is going to be equal to the weight of the actual compound, which says carbon weighs 113 grams. So carbon to carbon, and then total to total. We cross multiply to solve. We get 36x equals 113 times 78. Divide each side by 36. Let me see here. By divisibility rules, I know that 78 is divisible by 3 because 8 plus 7 is 15. 15 is divisible by 3, so 3 can go into both of these. 3 goes into 36 exactly 12 times. 3 goes into 78. I'm not sure. Let's see here. 2, 1, 6. 3 goes into 28 26 times. So we've got 12 over 26. This will be divided by 2 to become 13. This divides by 2 to become 6. So I've got 113 times 13 over 6, and I think that's all we're going to get out of it. We just have to multiply 113 by 13. Now, because this video has gone on so long, I'm going to go ahead and use a calculator. But that's all right, because you can too. So we'll take 113 times 13 gives us 1469 divided by 6, and we get 244.83 repeating. So our answer is going to be 244.83 with a line over it, grams. And that is correct. Sorry for the long video. Have a good day.